In total, as of May of 2025, there were 47 rocket launches which had the main goal of reaching Mars. Of those 47 rocket launches, quite a few had missions with more than just one goal. Rather, many had the intention of putting a satellite in orbit, but also deploying a lander or a rover. Still, at the moment, the majority of the missions to Mars failed, and pretty much all of those failed missions are at this point largely forgotten. This video is going to cover, in a chronological order, all of Mars's forgotten missions that happened before the year 2000. So yes, this video is going to skip the examination of Spirit, Opportunity, Curiosity, and Perseverance, which are probably the most legendary Mars missions as of now. However, although this video is going to be mostly about failed and partially failed Mars missions, even quite a few successful missions are going to be examined because they are also largely forgotten at this point. The first ever attempt at getting to Mars happened on October 10th, 1960. It was an attempt by the Soviet Union. By NASA, the mission was called Mars 1960A. Surprisingly, even some of the Soviet scientists that were involved with the Mars program at the time claimed to not know of this launch and mission. Apparently, some of them only knew of the second Mars mission, which was launched just 4 days later. How long it took for the news of this mission to get to NASA is not known, but NASA did report the existence of this mission by at least 1962. As for the launch, it happened at the Baikonur Cosmodrome. It is a spaceport located in what is today Kazakhstan. This spaceport was used for every single Soviet launch for the Mars missions. Just like NASA launches typically happen in Florida, the very southern part of the United States, so did the Soviet launches happen in the very southern part of the Soviet Union. Although even this very southern part of the Soviet Union is very northern on a global scale. The Baikonur Cosmodrome is at a latitude of 45 degrees north, halfway to the North Pole. 45 degrees north is further away from the equator compared to most of mainland United States, and with that it is much further away from the equator compared to Cape Canaveral, which is in Florida at 28 degrees north. Cape Canaveral is typically where rocket launches happen in the US. The reason locations closer to the equator are preferred when it comes to rocket launches is because it saves up on the rocket fuel required, and it gives an additional boost to the rocket because it keeps the momentum of the Earth's rotation. And the Earth's rotational speed is greater at places that are closer to the equator compared to the ones that are further away. What you are looking at in this photo is the Soviet Venera 1 spacecraft, which is nearly identical to the Mars 1960A spacecraft. So because the photos of Mars 1960A aren't widely available, for illustration purposes, this image of Venera 1 spacecraft is useful. The Venera 1 spacecraft launched in February of 1961, so about 5 months after the launch of Mars 1960A. Essentially, the Soviet space program reused the Mars 1960A model, but intended with it to do a flyby of Venus. And the spacecraft did manage to approach Venus at a distance of about 100,000 kilometers. It is the first flyby of Venus. However, it wasn't able to return useful data from the instruments during the flyby because it was out of power, possibly as a result of the solar panels failing to orient themselves towards the sun. The Mars 1960A spacecraft is quite large. This image of the spacecraft doesn't give a good sense of scale. It was about 2 meters tall and it had a mass of 650 kilograms. This spacecraft was launched on a then new rocket called Molniya. This was the first launch this rocket design had. It is a 40-meter tall rocket, pretty much the height of a residential building. And the first stage of the rocket successfully carried the probe into space. However, once the second stage of the rocket was activated, the vibration from the ignition damaged its steering capability. 309 seconds after launch, the engine was shut down. The rocket managed to go up to 120 kilometers above the ground. So it did officially reach space, which starts at about 100 kilometers above the ground. Then, after reaching that high point, it started to go back down. Eventually, as it was falling, the spacecraft got shattered and the pieces of it got scattered throughout eastern Siberia. The Mars 1960A probe carried several different instruments. One of them is the ultraviolet spectrometer. It was intended for the study of Mars's atmospheric composition. It also had a radiation detector. This is particularly useful for determining what sorts of radiation exposure could be expected on human flights to Mars. But beyond that, it is also just useful in the case of some truly unexpected levels of radiation, one that could even potentially damage future spacecrafts, landers, and rovers. And finally, the spacecraft had a cosmic ray detector. Cosmic rays are high-energy particles. They are frequently released by the sun. Most of those rays are just atoms without electron shells, so just the nucleus of atoms. The spacecraft also had 2 solar panels. Obviously, it was intended for these solar panels to power up the instruments and send data back to Earth. The spacecraft also almost had a television imaging system that would be used for imaging Mars up close. However, it was removed because the payload mass had to be under a certain point. Another instrument that was removed is a spectral reflectometer. This device is used to determine how well a surface absorbs heat. This is mostly useful for monitoring the spacecraft, as it could determine which parts have excess heat that could degrade parts of the spacecraft. Mars 1M NO2, also known as Mars 1960B by NASA, is a Soviet spacecraft launched only 4 days after the Mars 1968 spacecraft. So the launch occurred on October 14, 1960, and it occurred on the same spaceport. And the rocket that the spacecraft was carried on was pretty much the same design. And along with that, the spacecraft itself was pretty much a twin of 1968, so it carried all of the same instruments on its launch. Well, the rocket did achieve a liftoff, so it launched, but a part of the engine failed to ignite after it was already in air. Then, of course, because of the failed ignition of the engine, the rocket started falling, and it broke up in the atmosphere along with the spacecraft carried on the rocket. The reason the engine failed to ignite is because while the rocket was already on the launching pad, the liquid oxygen stored in the second stage of the rocket leaked, and that liquid oxygen leak lowered the temperature of where the kerosene fuel was stored to the point at which it got frozen, so the fuel couldn't be ignited while in air. So the first 2 attempts at getting to Mars failed, and they did so pretty hard. But the Soviet space program was still at this point far from giving up on getting a successful mission to Mars. This is especially true because they already built up a lot of momentum with 2 successful missions to the moon. One which intentionally crashed a spacecraft into the moon, a first, and the other which was the first to photograph the far side of the moon. Mars 2MV3 NO1 is a 3rd attempt at getting to Mars. This mission is also known as Sputnik 22. This is another Soviet mission that had the intention of getting a spacecraft to do a flyby of Mars. The rocket launch carrying the spacecraft happened 2 years after the previous 2 failed attempts. It happened on October 24, 1962. The rocket reached a low Earth orbit, however, then the main engine exploded, shattering what was left of the upper stages of the rocket with the spacecraft. Much of the debris was left orbiting for a few months before getting back down to Earth. So, another big failure. The spacecraft only had 2 instruments, an imaging system and a magnetometer, which measures the strength of magnetic fields. Mars 1 is a Soviet spacecraft launched in 1962, just 8 days after the previous Soviet Mars spacecraft. This time, the Molniya rocket managed to get the spacecraft out of Earth's orbit and successfully on its way to Mars. Finally, some progress. The spacecraft, while it was going away from Earth, also registered micrometeorite strikes with an instrument. It also registered solar winds and different magnetic field intensities even in interplanetary space. It had a magnetometer. It also had radiation sensors. And it had a spectrograph, which is useful for analyzing atmospheres. So these instruments allowed for the spacecraft to return some useful scientific data. However, what they didn't manage to do is return useful data of Mars. And that is because a bit more than halfway on its way to Mars, 5 months after its launch, the spacecraft stopped sending back data to Earth. Likely that is a result of the antennas failing to orient themselves properly. The spacecraft, however, did perform a flyby of Mars in June of 1963, approaching Mars at a distance of 193,000 kilometers away, quite a bit closer than the Moon is to Earth. Still, although interesting, and although a huge leap compared to previous attempts, this flyby, of course, is still overall a failure because it didn't return any data from its closest approach to Mars. Mars 2MV3 NO1, also known as Sputnik 24, is the fourth attempt at getting to Mars by the Soviet Union, but this time the intention was to get a lander on Mars. The launch happened in 1962, just 3 days after the launch of Mars 1. However, unlike Mars 1, Sputnik 24 was a hard failure. The lower stages of the Molniya rocket delivered the spacecraft into orbit around Earth, but the upper stage of the rocket, which was made such that the spacecraft leaves the orbit of Earth, while the upper stage engine failed to ignite, likely because the fuse controlling the upper stage got dislodged. With that, the spacecraft was left stranded in orbit around Earth, and the next day it fell down and got destroyed. However, some of the debris from the rocket stayed in orbit around Earth for months. After 2 years of no launches by anyone to get to Mars, the United States, and with that NASA, finally had their first attempt at getting a spacecraft to do a flyby of Mars. The Mariner 3 spacecraft was carried by a 36-meter tall rocket called Atlas LV-3 Agena D. The launch happened on November 5, 1964 in Cape Canaveral, which is, as mentioned, in Florida. The spacecraft successfully left the Earth and was on its way to Mars. However, it was known very shortly after the launch that the mission is still a failure. The top of the rocket, the shroud in which the spacecraft was located, well, it stayed in place, and despite the commands which were sent specifically to get rid of it 8 hours into the mission, because the solar panels were unable to be deployed, the spacecraft ran out of power and the mission obviously failed. However, just 23 days later, on November 28, 1964, another attempt was made at getting to Mars by NASA, with the same rocket design at the same location. The launch was successful, and the Mariner 4 spacecraft successfully performed the first ever flyby of Mars about 8 months after launch in July 15, 1965. The spacecraft approached Mars at a distance of about 9,800 kilometers, a very close flyby. Now, the failed Mariner 3 and the successful Mariner 4 spacecraft were twins. They had the exact same design with the exact same instruments. Interestingly, despite the Mariner 3 and 4 spacecrafts having more instruments than any of the previous Mars Soviet spacecrafts, they also had a lower mass. They had a mass of about 260 kilograms. Meanwhile, the lightest previous Mars Soviet spacecraft, Mars 1960A and B, each had a mass of about 650 kilograms. And it's worth mentioning that the Mariner spacecrafts were also not small either. This image gives a good sense of scale. From one end of the solar panel to the other, it had a span of nearly 7 meters. Also, it is worth mentioning that, unlike the Mariner 3 mission, the Mariner 4 mission is not really obscure. After all, it performed the first successful flyby of Mars, and it returned a bunch of scientific data, along with the first ever up-close images of Mars. So this is one of the most iconic missions in the space race history. Just 2 days after the Mariner 4 launch, the Soviet spacecraft called Zond 2 was launched on November 30th, 1964. The reason the 2 Mariner launches and Zond 2 launch happened in the same month is because that was the time window during which getting to Mars is relatively quick. The heavy 890-kilogram Zond 2 spacecraft was successfully launched into space. But in May of 1965, the communication with the spacecraft was lost just 3 months before the closest approach to Mars. It did approach Mars at a distance of about 1,500 kilometers. But of course, because of the lost communication, it simply didn't get to use any of its 8 instruments. Another failure. For a bit more than 3 years, there were no launches to Mars by anyone. But finally, on February 25, 1969, the spacecraft Mariner 6 was launched into space, a third mission in the Mariner program for getting to Mars. Then about a month later, on March 27, 1969, the Mariner 7 spacecraft was launched, which is a twin of Mariner 6. As we can clearly notice, the strategy of sending multiple twin spacecrafts at once was practiced frequently during these early Mars missions, not just by NASA but also by the Soviet space program. This is because the US and the Soviet Union were competing in terms of getting space achievements, so to ensure success, they implemented redundancy by making twin spacecrafts launched in a similar time window. Now, before Mariner 6 and 7 reached Mars, this is how the best global map of Mars looked like. Very blurry, but just enough to recognize certain features like large dark spots and polar caps. But it wasn't known what the ice caps are made out of. The atmospheric composition of Mars was also unclear at the time. It wasn't known whether or not the surface is shielded from solar winds. Mariner 6 and 7 cleared up a lot of the unknowns that were surrounding Mars. It was discovered that Mars is riddled with radiation. Pretty clear images of the surface of Mars were captured, enough to conclude that the surface of Mars is, in a lot of areas, very moon-like. That is, filled with craters, and with that, geologically dead. But also vast smooth areas were also captured, which was a surprise. We now know that Mars is divided into two areas, the cratered highland south and the vast plain that mostly occupies the north. This contrast feature of Mars is called the Martian dichotomy, and it still isn't known for sure as to what caused it. Mariner 6 also managed to image what is now known as Olympus Mons, the tallest planetary mountain in the solar system. It has a height of about 22 kilometers. At the time, however, it still wasn't certain as to what this feature is, although the extremely elevated nature of Olympus Mons was suspected even way before this flyby, all the way back in the 19th century. The shield volcano is so large, even some of the best telescopes that far back were able to observe it. Mariner 7 also captured a pretty good image of one of the polar caps. There was some disagreement in the Mariner team as to what they were looking at. Some said that it was water ice, while others said that it was carbon dioxide, as the registered temperature at the poles is in line with the carbon dioxide being frozen. By this point, we now know that the top layer of the Martian poles is carbon dioxide ice, and it is present at its greatest during winter. And beneath that carbon dioxide layer does actually lie water ice. Also, the Mariner scientists at the time, from the data gathered from the flybys, also correctly concluded that the thin Martian atmosphere is mostly carbon dioxide. First, Mariner 6 was launched, and Mariner 6 reached Mars before 7. And during the moment where it was approaching Mars very closely, the communication with Mariner 7 stopped, and this was also a bit less than a week before Mariner 7 was supposed to make its own closest approach to Mars. Seemingly, it was dead right at the finish line. However, another backup antenna that the spacecraft had started working, and the communication with Mariner 7 was regained. Based on the images that Mariner 6 provided, then the path of Mariner 7 was modified such that a specific area was captured with the instruments. There was also quite a bit of a debate as to what area that should be. Ultimately, Mariner 7 made its closest approach to Mars at a distance of 3,400 kilometers, and it successfully returned data. It also returned better quality images compared to Mariner 6, despite both of them being very similarly far away from Mars at their closest approach. Currently, Mariner 6 and 7 are orbiting the Sun, and they aren't transmitting any data back to Earth. Looks-wise, Mariner 6 and 7 are very similar to that of Mariner 3 and 4. However, Mariner 3 and 4 were about 260 kilograms, but 6 and 7 about 380. So although they looked similar, they are really quite a bit different. One part of the reason is also because their instruments differed significantly. On the exact same day that the Mariner 7 launched, on March 27, 1969, the Soviet Mars 2M NO 522 also launched. This mission intended to send an orbiter to Mars. Even a lander was intended, but the idea was scrapped later, likely as a result of the fact that this orbiter was ridiculously heavy, leaving no room for the lander. The orbiter was about 4,800 kilograms. So yes, the Soviet space program decided that it was time to skip the flyby missions entirely. The United States already did that, and they were competing in being the first in a category. This time, the launch for this mission finally happened on a different rocket design, the Proton K rocket, a rocket design that would be used for every single Mars mission that the Soviet Union had after. Potentially what sparked the desire for change is the success of the Mariner 4 flyby. Although the Soviet space program had a lot of success with Venus, more than NASA, they were really losing the race to Mars. And this was another failed attempt. The first and second stage of the rocket went okay, but the third stage exploded, which destroyed the probe in the process. A couple of days after this unsuccessful launch, Another attempt was made by the Soviet space program to launch the Twin Orbiter. The launch happened on the same rocket design on April 2nd, 1969, and within the first minute after liftoff, the mission clearly failed. The rocket eventually came crashing down. This was especially devastating because it was known by the engineers that both Mariner 6 and 7 launch were successful. After 2 years of no missions to Mars, another launch window to Mars opened, and NASA launched the Mariner 8 spacecraft on May 9, 1971. This Mariner spacecraft was intended to be an orbiter. After 3 successful flyby missions, the age of doing Mars flybys as the main mission is by this point over. The next flyby mission that NASA did happened in 2018, but it was a part of the InSight lander mission. The Mariner 8 spacecraft was quite a bit heavier and capable of producing much more power from its solar panels compared to the previous Mariner spacecraft. However, the instruments present on the spacecraft were very similar to that of Mariner 6 and 7. But of course, the same instruments in orbit around Mars are going to deliver much more interesting information compared to just a mere flyby. So this was a very significant attempt. Mariner 8 was launched on a similar rocket design to that of the previous Mariner missions, but this time the upper stage of the rocket started tumbling, eventually leading to the upper stage and the spacecraft crashing into Earth. Although bad, this is the last time NASA had a rocket launch for Mars that failed to get beyond Earth. There are some failed NASA Mars missions in the future, of course, but none that failed this hard. Cosmos 419 is a Soviet spacecraft launched just a day after Mariner 8, so on May 10, 1971. Yes, it was another orbiter mission, also with the Proton K rocket, but the rocket launch failed. However, it still wasn't over for this launch window. In 1971, Mars was exceptionally close to Earth, and during this time window, the Soviet space program made 3 spacecrafts that were intended to launch in the same month. This crazy amount of redundancy emphasizes pretty clearly just how badly the Soviet space program wanted to have their Mars achievements. And with the next launch, their bad luck turned around by quite a bit. After 9 failed Mars missions, that one was the first to succeed for them, at least mostly. The Soviet Mars 2 spacecraft was launched 9 days after Cosmos 419, so on May 19, 1971. But unlike Cosmos 419, the Mars 2 spacecraft was extremely ambitious, carrying not only a lander but also a rover. So the Mars 2 spacecraft was successfully launched, and it got into orbit around Mars, and with that it became the second spacecraft to orbit another planet. But what happened to the first spacecraft to orbit another planet? Well, turns out, although Mariner 8 failed to launch on the 9th of May, Mariner 9 launched on the 30th of May so successfully that despite the fact that it launched 11 days after Mars 2, it reached Mars nearly 2 weeks before the Mars 2 orbiter. And it gets even more interesting. 2 days before the Mariner 9 launch, on the 28th of May, the Soviet Mars 3 spacecraft was launched. It also successfully launched, and it reached Mars on December 2nd, 1971, so it reached Mars about a week after Mars 2, and 3 weeks after Mariner 9. With that, it became the third spacecraft to orbit another planet. Both Mars 2 and 3 had the same design, and yet they had very different orbits around Mars. Mars 2 completed an orbit around Mars every 18 hours. Mars 3, on the other hand, completed an orbit every 12.6 days. The reason its orbital period was so much greater is because Mars 3 didn't have enough fuel to put itself into a short period orbit. Rather, with the little fuel that was available, it was decided for it to enter into an extremely elongated orbit that lasts for quite a while. About 9 months after Mars 2 and 3 entered into orbit around Mars, the missions were concluded, but by that point, Mars 2 completed a total of 362 orbits, while Mars 3 only about 20. Interestingly, after such a long time around Mars, both orbiters only sent back about 60 pictures of Mars. Also, pretty much as soon as Mars 2 and 3 arrived, they dropped their landers on Mars. Inside the landers was a rover, so if the lander failed to safely land, then the rover also certainly failed. The lander itself for Mars 2 and 3 was about 358 kilograms, while the descent module, the thing that was supposed to deliver the lander safely to the ground of Mars, was 852 kilograms. However, the parachute on the descent module failed to deploy, and the lander and with that rover crashed directly into the surface of Mars. Unlike Mars 2, the Mars 3 lander, on the other hand, did safely land on the surface of Mars, so with that it became the first lander to make a successful soft landing on Mars. A minute and a half after landing, the lander started sending data back to the Mars 3 orbiter, but very shortly after, it stopped sending back any data, and all we got back to Earth was ultimately just a very low quality image of Mars. The quality is so low that no feature can be recognized. With that, the rover was also not deployed. All communications stopped by that point. Potentially the reason the Mars 3 lander failed to send back data to Earth for long enough is because right when the Mariner 9, Mars 2, and also Mars 3 arrived, on Mars there was a dust storm engulfing the entire surface area of the planet. The atmospheric dust possibly interfered with the ability of the lander to send data, so it could be the case that the unpredictable circumstances are what made it so that the Soviet space program failed at achieving at least one space first with regards to Mars. The rover that was attached to the Mars 2 and 3 lander was also very odd. It was called Prop M. It was this box-shaped object with these two legs that were intended to move up and down in order to produce movement. There were no wheels, and its unique design allowed it to go at a speed of about 1 meter per hour. The rover was planned to be deployed by an arm that was attached to the lander. The arm would take the rover and place it on the ground. The rover, however, was also attached to the lander with a 15-meter cord, so even if the rover successfully deployed, the cord didn't allow for significant autonomous movement. Also, in comparison to the lander, this rover was tiny. It had a mass of only 4.5 kilograms and a diameter of about 25 centimeters. Now, the Mars 2 lander and rover crashed into Mars, and there are no known traces of where that object is. The general latitude of where the crash site is estimated, but there is uncertainty. However, the Mars 3 lander and rover are still intact, and that safe landing made it a lot easier to spot the lander. Because its parachute was deployed, and the parachute left behind was very likely spotted in one of the images captured by NASA's Mars Reconnaissance Orbiter, which reached Mars in 2005. Mariner 9 is a relatively well-known mission, at least quite a bit more compared to the previous Soviet missions. Unlike Mars 2 and 3, which together returned only about 60 pictures of Mars, the Mariner 9 spacecraft returned 7,329 photos, and with that it covered 85% of the surface area of Mars. The Mariner 9 orbiter mission concluded only about 2 months after the conclusion of the Mars 2 and 3 mission, so it didn't last a lot longer. The spacecraft carried similar instruments to the ones found on Mariner 6 and 7, and it is a twin of the Mariner 8 spacecraft, which failed to reach Mars. Mariner 9 also definitively concluded that Olympus Mons is in fact an extremely tall shield volcano, so the elevated nature of the feature, which was observed for a long time before the visit, was finally confirmed. The current location of the Mariner 9 spacecraft is unknown, but it was estimated that its orbit decayed already a few years back, around 2020, so it likely crashed into Mars. After 2 years of no launches to Mars, the Soviet space program decided to make their most ambitious attempt at getting to Mars. On the 21st and 25th of July 1973, two twin spacecrafts, Mars 4 and Mars 5, on two separate Proton K rockets were launched. The launches were a success as they successfully left the Earth. The spacecraft, which was launched first, also was the one to first reach Mars on February 10th, 1974. However, it didn't manage to become an orbiter, as a week and a half after the spacecraft was lifted off of Earth, two computers that it had, which were performing maneuvers, failed, which left the Mars 4 spacecraft on a course to do a flyby, meaning it wasn't able to become an orbiter, which is what the spacecraft was intended to do. Still, the flyby was successful at least, and it did manage to return at least some data from the flyby, so this mission is a partial success. But sadly, it just didn't get to fully use its 15 different instruments. Now the Mars 5 spacecraft, which was launched 4 days after Mars 4, well, this spacecraft successfully reached Mars, and it successfully got itself into a 24-hour-long orbit around Mars. It reached Mars on February 12, 1974. so 2 days after Mars 4 performed a flyby of Mars. Mars 5 was still only able to deliver data back to Earth for just 16 days, something which wasn't intended. The orbiter mission was intended to last for at least 3 months. Possibly the reason the mission didn't last long enough is because of a micrometeorite impact which caused for the instrument compartment, which was pressurized, to leak. Still, this spacecraft did at least manage to use its instruments a lot more thoroughly compared to Mars 4. It returned 43 photos of Mars which were usable, and it also got to use its gamma ray spectrometer, and it found a similar surface composition to that of volcanic rock on Earth. One somewhat interesting thing about Mars 4 and 5 is that they have the same design of the previously launched Cosmos 419, the spacecraft that didn't manage to get beyond Earth 2 years earlier. The Soviet space program had another 2 launches in the same time window. Nearly 2 weeks after the launch of the Mars 5, on August 5, 1973, the spacecraft Mars 6 was launched, and 4 days later, on August 9th, the spacecraft Mars 7 was launched. But these 2 twin spacecrafts were not intended to be orbiters. Rather, it was intended for them to do a flyby, during which each of them would drop their landers, which are also twins. So the launches were successful. They got beyond Earth and were headed for Mars. Although Mars 6 was launched 4 days earlier, Mars 7 reached Mars faster. Specifically, it reached Mars 3 days before Mars 6. On its closest approach, Mars 7 tried to deploy its lander, and it did manage to separate from the spacecraft, but the lander just missed Mars. The Mars 6 spacecraft, with its own lander, arrived on Mars 3 days later. It successfully dropped its lander. Its parachute got deployed, and while approaching Mars and going through the atmosphere for nearly 4 minutes, the lander was sending back data. However, it was largely unusable because one of the systems through which reliable data was gathered failed. Beyond that, just as the lander was about to have its rockets fired in order to slow down the descent, the lander just entirely stopped sending back data. So the Mars 6 and 7 flybys were successful. The landers were not. Both Mars 4 and 5 were intended to be orbiters that would be used by the landers for them to relay information to. However, we now know that even if the landers successfully landed, they wouldn't be able to relay information to Mars 4, as it simply wasn't able to become an orbiter. And Mars 5 was able to send back data to Earth for just 16 days, meaning its contact with Earth ended 10 days before the Mars 7 approach and 13 days before the Mars 6 lander attempted to land on Mars. So this was probably the most ambitious Soviet space program project for Mars. 4 separate launches happening within a single year, all intended for Mars, but it just didn't work out. Even Mars 2 and 3 were a lot more successful overall. After this extremely ambitious attempt at getting to Mars, the Soviet space program didn't have a single mission to Mars for the next 15 years. After 2 years of no launches to Mars by anyone, NASA's Viking 1 launched on August 20th, 1975, and Viking 2 launched on September 9th, 1975. Now, these missions are pretty famous, so let's just get a quick overview. Viking 1 and 2 were both orbiters that also had landers with them. Both of them successfully reached Mars, and both of them successfully deployed their landers. Viking 1 is the first lander to successfully land on Mars, and also sent back photos of its surface, and the photos were very good. This is the first time people ever got to see the surface of another planet in such stunning detail. The Soviet Venera lander was indeed the first lander to ever land on another planet, but the images that lander returned were just okay. Viking 1 delivered something on another level. The Viking 2 photos from the surface of Mars were also just as good. These 2 landers, along with the orbiters, are some of the most scientifically productive space missions of all time. Before that, knowledge with regards to Mars was a lot more speculative. One of the reasons they could be so productive is because both of the Viking landers and the orbiters operated for about 3 years or more. Specifically, the Viking 1 lander operated for 6.3 years. So until November of 1982. That is also one of the reasons NASA wasn't really in a hurry to get to Mars again. And the Soviet space program, likely because of the immense success of the Viking missions, didn't have much of a reason to go back to Mars, and rather they focused on their strengths, which is sending landers and orbiters to Venus. Because of these circumstances, after the launch of the Viking 2 spacecraft, which happened on September 9th, 1975, there wasn't a single launch for Mars for the next 13 years. This makes it currently the longest time period during which there were no launches set for going to Mars, and it is the longest period by far. The longest period of no launches was finally broken by the Soviet Phobos 1 launch. It is a spacecraft that was intended to be an orbiter of Mars, but the primary goal of the spacecraft was studying Mars's small asteroid-shaped moon called Phobos, because this was at the time a way of getting another space first. Phobos has a diameter of about 22 kilometers. Now yes, this isn't exactly a mission specifically dedicated for Mars, but since Phobos is so close to Mars, inevitably studying Phobos would also lead to the study of Mars. Phobos orbits Mars at a distance of just 9,300 kilometers away from the center of Mars, meaning it is closer to Mars than the closest approach the spacecraft Mariner 4 had to Mars. The Phobos 1 spacecraft was also intended to orbit Mars. The spacecraft successfully launched on July 7th, 1988, but nearly 2 months after it launched, while it was on its way to Mars, the spacecraft stopped sending back data to Earth. What happened is that a command was sent to the spacecraft which contained an error. The system which was supposed to proofread the commands failed, and ultimately that led to the spacecraft being unable to position its solar panels towards the sun, which led to the batteries being drained, and with that the spacecraft was left with no power. Disciplinary action towards those who caused the spacecraft to fail was postponed so as to ensure that the Phobos 2 team, which was controlling the Phobos 2 spacecraft, was going to do their job properly, as in they didn't want to make them scared. Phobos 2 spacecraft was launched on July 12th, 1988, so about 5 days after Phobos 1. While on its way to Mars, 2 of its computers malfunctioned, but the spacecraft was still able to reach Mars on January 29th, 1989, and Phobos 2, along with Phobos 1, was also meant to deploy a lander on the surface of Phobos. It was set for the Phobos 2 spacecraft to approach Phobos at a distance of only 50 meters, but on March 27th, 1989, the spacecraft stopped communicating, and because of that, the landers were not deployed. Although deploying the lander failed, the spacecraft did manage to get pretty good photos of the moon Phobos. The majority of this moon's surface was photographed because of Phobos 2. Phobos 2 is also the last mission the Soviet space program had for Mars. That is because shortly after the mission, in 1991, the Soviet Union completely dissolved. After 4 years of no missions to Mars, on September 25th, 1992, NASA's spacecraft called Mars Observer was launched successfully. However, only 3 days before the closest approach to Mars, the contact with the spacecraft was lost. It even got to photograph Mars with its extremely powerful Mars Observer camera the month before the communication stopped. It isn't known as to whether or not the spacecraft got itself into orbit around Mars, but that is what it was programmed to do. What likely caused the spacecraft to fail is a fuel and gas leak, which propelled the spacecraft in such a way that it started spinning, which then interrupted the commands it was supposed to perform. Although this mission was largely a failure, it wasn't all wasteful. That is because the designs for the powerful instruments were reused successfully on future NASA Mars missions. After 4 years of no missions to Mars, NASA's Mars Global Surveyor spacecraft was launched, and it successfully reached Mars and became an orbiter on September 11th, 1997. Equipped with the Mars Orbiter camera, pretty much the same as that one for the Mars Observer, the spacecraft was able to photograph the surface of Mars in a detail never seen before. Gullies, valleys, carbon dioxide jets on the South Pole, the odd hole pattern present on the South Polar Cap, and so on. The Viking orbiters just didn't deliver the same resolution. Besides the powerful camera, what also allowed for the photos of this quality is the fact that the spacecraft was only between 370 kilometers and 430 kilometers away from the surface of Mars, so very close. That is pretty much the same distance that the International Space Station is away from the surface of Earth. But probably the most significant experiment from the Mars Global Surveyor came from its laser altimeter. By sending a laser onto the surface of Mars, through the amount of time that it takes for the laser to hit the surface and get back to the instrument which sent the laser, a distance between the spacecraft and the ground can be determined. And with that, the height of objects can also be determined. That then allowed for the formation of Mars's pretty famous topographic map. This map is incredibly useful when wanting to clearly showcase some of its features which get washed away in real color. The Mars Global Surveyor spacecraft also managed to photograph Mars Odyssey in 2005. That is, another NASA spacecraft which arrived on Mars in 2001. This made Mars Global Surveyor the first spacecraft to image another spacecraft on another planet. The Mars Global Surveyor spacecraft mission lasted for 10 years around Mars, a lot longer than what was expected. On November 2, 2006, the spacecraft sent its last signal. What caused the failure to contact the spacecraft further was a software update that contained an error. 9 days after Mars Global Surveyor launched, instead of the Soviet space program, this time the Russian space program launched its Mars 96 spacecraft on the 16th of November 1996. It was an extremely ambitious mission that consisted of an orbiter along with 2 landers and 2 penetrators which were designed to crash into the surface of Mars, survive the crash, and get about 5 meters into the ground. A bunch of instruments were attached to the penetrators, and with that it would reveal things never known before. The entire 96 probe was gigantic. This image gives a sense of scale. The orbiter, along with the fuel, was about 6,000 kilograms. The probe was supposed to be an improvement on the Phobos 1 and 2 design. However, Mars 96 failed. It didn't even get beyond Earth, and it eventually crashed, likely somewhere in South America. Also in 1996, just 19 days after the launch of Mars 96, NASA launched the Mars Pathfinder spacecraft, which is a lander that also contained a rover. This mission isn't really forgotten. It is one of the most iconic Mars missions because Mars Pathfinder successfully landed on the surface of Mars, delivered high-quality images, and on top of that successfully deployed a rover on Mars for the first time ever. And not only that, NASA also proved with this mission that space exploration missions could be a lot cheaper, as that was one of the main goals with the mission. And they did so successfully because the Viking missions costed many times more than Mars Pathfinder. Nozomi was a spacecraft by the Japanese Space Agency developed to be a Mars orbiter. It was successfully launched in July of 1998. However, during the course correction it used too much fuel, so much that it didn't have enough left to get into orbit around Mars. So then it just got put into orbit around the Sun, and the mission changed from studying Mars to studying interplanetary space, and with that the Sun. This spacecraft also did eventually get to do a flyby of Mars, but it was just a flyby. Over time, NASA's Mars orbiters started getting heavier and heavier, eventually reaching the point of being around 1,000 kilograms. That was the case for the Mars Observer and the Mars Global Surveyor. But due to budget constraints, the Mars Climate Orbiter was made to be relatively small, about 600 kilograms. It carried just 2 instruments, which were carried over from the failed Mars Observer. It had a camera and a pressure-modulated infrared radiometer, which would allow it to study dust concentration, water vapor, atmospheric pressure changes, temperature differences in the atmosphere between different parts, and a few other things. But this mission failed. It successfully launched in December of 1998, but when it reached Mars, it failed to enter into orbit, and it either missed Mars or crashed into it. Turns out, what caused the spacecraft to not insert itself into orbit was related to a software error, a mismatch between 2 different systems using 2 different units. There was a conflict with standard US units, which were used by a system which the contractor made, and the other system, which was made by NASA, which used metric. NASA's Mars Polar Lander successfully launched, and it reached Mars on December 3, 1999. It reached the South Pole, where it was supposed to land, and then the lander stopped communicating. One of the likely possibilities suggested that as the lander legs got deployed while it was in air, the vibrations caused the spacecraft to act as if it landed on the ground, which shut down its descent engines and caused it to crash from a distance of several tens of meters. So again, this was likely due to a software error which led to the lander failing. And this failure happened 2 months after the failure of the Mars Climate Orbiter, which also makes this the first time NASA had 2 Mars mission failures in a row. However, going forward, not a single NASA mission for Mars failed as of 2025, and there were 9 of them since the Mars Polar Lander. Along with the Mars Polar Lander, There were also 2 penetrators, Deep Space 1 and 2, which were supposed to strike the surface at the South Pole, get about a meter deep into the ground, and send back data, but communication was also lost. The Mars Polar Lander mission was largely interested in answering the question of whether or not there is water ice beneath the Martian poles, something that we now know is the case. However, this failure is still pretty devastating, considering that every single successful Mars lander and rover was either around the equator or in the north. Most of them are in the huge North Polar Basin, the largest basin in the solar system, so we just don't know what the truly southern Martian landscape looks like up close, especially not the South Pole. The Martian Polar Lander is likely currently now at a latitude of 76 degrees south. Not a single lander or a rover is that far away from the equator. The spiritual successor of the Mars Polar Lander is the NASA Phoenix lander, which landed on Mars back in 2008 at 68 degrees north, and it did capture this unique alien landscape that is that far north. Specifically, it captured a polygonal cracking pattern in the Martian permafrost, which is likely just water ice. Even upon landing, the bright patch of ground below it was revealed to be water ice. Still, the South Polar region has different features with a different terrain. In general, as already mentioned, the southern hemisphere of Mars is a lot more cratered and chaotic compared to the northern one, which is largely a craterless, almost featureless plain. Only the largely failed Soviet Mars 2, 3, and 6 landers were well into the southern highlands. Other rovers and landers which were successful are either very close to the equator or well into the northern hemisphere, so the failure of the Mars Polar Lander is still very significant. Now, to top the disappointment off in terms of exploring a variety of Mars locations, the European Space Agency should launch its rover called Rosalind Franklin with the intention to land also in the North Polar Basin, at the outflow channels somewhat close to the largest valley in the solar system. Although it could be scientifically interesting, it isn't very likely that this location is going to provide something truly unique. Around that area is also where Viking 1, Pathfinder, and Opportunity already were. This decision still leaves countless other very interesting huge Mars regions entirely unexplored. For example, the gigantic and extremely deep Hellas Planitia Basin, or somewhere next to the tallest planetary mountain in the solar system, or very close to the South Pole. It's not like these locations are scientifically uninteresting. These could also provide some very unique knowledge, and to top that off, somewhere in those locations, there is also evidence of past liquid water. So this video covered all 32 launches for Mars that happened before the year 2000. The majority of these missions are by this point pretty obscure, which is why this video covered them. After the year 2000, there were additional 15 launches specifically for Mars as of 2025, and most of those are pretty well known due to how recently they happened. However, as time goes on, a lot of those are probably going to fade into obscurity, just like the missions covered in this video.